These are some notes about domain and range. It is our Unit 3, Day 2 information. So just a reminder, if you notice, domain ends in in for input, for independent variable. All of our domain values are the x values, and so of course our x-axis on a coordinate grid is where we would find x values. Our range is going to be all of the y values or the outputs or the dependent variables. So on the coordinate grid, it would be values you find on the y-axis. Right, so we already covered that a little bit in some of our other notes, but we're going to talk about how we can write about domain and range. So the first thing I'm going to talk about is when we have a finite domain or range, when we have finite points. So I've just picked a coordinate grid system from another worksheet, and I'm going to remind you that finite points, you can see actual points on the coordinate grid. I could write ordered pairs for each and every single point on there, and it's a discrete number of points. There are 4 points on there. If I want to write about the domain for these values, I'm going to figure out what are all of the possible x values that I might have, because that's domain, right? So the x values I might have, this is -1, -2, -3, -4. That is at -4, so one domain value might be -4. This is here at 0, x equals 0. This one's at x equals 2. And this guy here is at 1, 2, 3, 4, +4. Okay, so those are the only possible x values I could use. That's my domain for this particular set of points. I can find that also if I wanted to write out every single ordered pair. So this ordered pair is -4, 3. The next ordered pair is 0, 1, right? This would be 2, 1, 2, 3, 4, 5, 2, 5. And my last point is at 1, 2, 3, 4, 1, 2, 3, 4, 5. 4, -5. So if I wanted to write out each ordered pair, I could find, here's my domain, all of the x's, -4, 0, 2, 4. So if I want the range, I'm going to say that the range is all of these possible y values. So I'm going to put them in numerical order, though, from least to greatest. It's going to be 1, oops, no it's not, it's going to be -5, 1, 3, 5. Those are the possible y values I might have. So far, when we've talked about domain or range, we've said we have a set of numbers, a set of values that we could possibly be using. But we're going to get a little bit fancier. So today, we're going to use set builder notation. Set builder notation. And so I'm going to tell you a set of information. I'm going to tell you that x is an element of the real number system. X is an element of the real number system. And then this vertical line just means such that. So x is an element of the real number system such that, in my case, I need to tell you what x can be. So I'm coming back to my grid, right? So if I'm talking about domain, I know that I'm talking about the x's, right? So it's the set of numbers x. X has to be an element of the real number system because that's all we're going to work with in this class. X is an element of the real number system such that x can equal any of these 4 values. Okay, so now I'm just going to plug that in. It's going to be -4, 0, 2, 4. Okay, and remember curly braces tells me I have a set of information. The thing is we are only working with real number system in this class, so far anyway, and so I'm going to shorten this. I'm going to kind of write this shorthand. The easier way to write it, we're going to take away element of the real number system, since that's true for all of the stuff that we do. I'm going to say x such that x equals -4, 0, 2, 4. I just wanted to at least tell you what that means. That is a Greek symbol that means element of, and then the r with a double backbone is the real number system. Okay, so this would be my domain, all my x's. And then, of course, my range has to be all of the y's, right? So I'm going to think about my range here, and it's going to be y such that y can equal any of these numbers. So I'm going to say y equals -5, or 1, or 3, or 5. Okay, it's that set of numbers. Notice that I didn't even say y is an element of the real number system, but it is, because that's what we're talking about in this class. All right, again, these are discrete points, specific points that I can see. So we can also have domain and range that has an infinite set of points. It is when we have a graph that we could draw without actually lifting our pencil. So here's an example. All right, back to my coordinate grid here. So if I have something that starts here, and it moves on, and then it ends over here. Okay, this line has an infinite number of itty bitty 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 little points, right? So I could write an infinite number of ordered pairs to describe every single point on here. So when I'm thinking about my domain, again, I'm thinking about all of my x's. So let's just think about what that looks like. This is my x-axis, right? So the very smallest x I could possibly have is right here. This is the smallest x I could have. -1, -2, -3, -4, right? The smallest x I could have is -4. The biggest x I could have over here is 1, 2, 3, 4, 5, right? So x is all of these values in between -4 and 5, right? X is in between -4 and +5. Okay, I'm going to notice that I have a closed circle here and an open circle there. So -4 could actually be the value for x, right? -4 is less than or equal to x. On the other hand, I can't really be 5, so that's just going to be a less than symbol. Okay, -4 is less than or equal to 5, which is less than 5. Nope, sorry, let me say that again. Sorry, I said it wrong. -4 is less than or equal to x, which is less than 5. That's my domain. It's all about the x's. Okay, so if I want to put that in set builder notation, I'm just going to put this right into set builder notation. So I'm going to tell you it's the set of numbers x such that x is in between -4 and 5. I'm just going to write exactly like I have that inequality statement. -4 is less than or equal to x, which is less than 5. And that's my set builder notation for the domain. Okay, if I want to talk about range, I'm going to think about the range. Range is all of my y values, right? So now I'm going to look vertically. And I'm going to start from bottom and go up to top. So from bottom to top, the smallest y I could have right here is 0, right? So 0 is the smallest y I could have. And then 1, 2, 3, 4, 5. I can go all the way up to 5. Okay, so any of my y values, they're going to fall in this little area right here, right? 0 to 5. So 0 is less than or equal to y, right? Because it's a closed circle. And y is less than 5 because 5 is an open circle. So if I want to write this in set builder notation, I'm just going to take that inequality statement and I'm going to tell everybody that I'm talking about y such that y is in between 0 and 5. I'm going to write it 0 is less than or equal to y, which is less than 5. Okay. All right, so let's take a look at your actual notes. And I think I'm going to make this a little bit smaller. Okay. We can have examples where we have all real numbers. The line continues on forever, ever, ever, left and right. And so we would go from -infinity all the way to +infinity, and I'll show you how to write that shortly. All right. So in a continuous graph, remember that's one where I can draw on the graph without lifting my pencil. Then I'm going to try to imagine my smallest to biggest. So if I'm thinking about domain, I'm going to go from left to right, right here. I'm going to go from the smallest possible x all the way to the biggest possible x. So we're going to go scan the x-axis from left to right to find all of the possible x's. And if it's a continuous graph and I need to find the domain, I'm going to scan the y-axis from bottom to top. And the reason I do that is that way I'm going to have all of my values in numerical order. Okay, so let's look at the next page. All right, here's a table of information. I have specific points. So this is going to be discrete points if I wanted to plot it out on a graph. I want to say, does this table represent a function? I'm just thinking about what I remember from last lesson. I look at the x values, and as long as there are no repeats, it's a function. So this is yes. What is the independent variable? Independent is input or x values. It's going to be our input and it's going to be our first column. This says miles. I know it's hard to read. This says hours. So in this case, they gave me miles first. Miles is my input. My independent variable is going to be miles. Right. Independent is my domain. So if I want to use set builder notation, I'm going to tell you the domain is x, such that x equals any of these possible inputs, right? X such that x equals 1 or 3 or 5 or 7. Okay. What is the dependent variable? The dependent variable is the output. It's the other variable, so I'm going to say that that's hours. That is the range, output, range, dependent variable. And so I'm going to tell you all about the range. The range is y, and it's y such that y must equal any of these numbers that we've been given. So we're going to say 2 or 6 or 10 or 14. Okay, so this is a table that I've been given information in, or here's a mapping diagram. First, I'm going to look and see, is it a function? I just look at all my inputs, and as long as each input only goes to one output, it is a function. So yes, it's a function. The domain, remember that's my input or my x value, so I'm going to say it's all of the x's such that x must equal any one of these, 1 or 2 or 3 or 4. Then I want to represent the range in set builder notation, so I'm just telling you all about the y's. Y such that y equals 1 or 5 or 9. That's it. Okay, so here we have yet another representation of the information. This is a set of ordered pairs, and so I'm looking, is this a function? I just need to look at all of my x values. Are there any repeats? Yes, there's a repeat. So 3 can go to 4 or 10. See that? 3 can go to 4 or 10. That means it's not a function, right? But I can still talk about the domain. It's all of my x values. X values such that x equals any of those possible x values. I'm going to put them in numerical order, and I'm not going to repeat anything. So the lowest one looks like it's 1, and it could be 2 or 3 or 9. Okay, and so if I want to represent the range in set builder notation, I'm talking about range, so I'm talking about y such that y equals any of my possible y's. So again, I'm not going to repeat if I see something show up more than once, and I'm going to go in order. 2, 4, 8, 10. 2 or 4 or 8 or 10. Oh dear. Represent in set builder. Represent the domain. I have put this in the wrong places. I'm so sorry. Pretend that I moved those down. Down here, the range y such that y equals 2, 4, 8, 10. I just answered in the wrong spot. Forgive me. This is my domain, so I know those are my x's. It's going to be x such that x equals 1, 2, 3, or 9. I just recorded in the wrong spot. Okay, over here, example number 4. I have another set of ordered pairs. So first, does this set represent a function? -3, -2, -1. Those are all different, so yes, it's a function. No repeats. Represent the domain. I'm going to do this in the right spot this time. Domain is all x's, so it's going to be x such that x equals... those came to me in order, so it's -3, -2, -1, 0, 1, or 2. Any of those could be my x. Represent the range in set builder notation. It's going to be y such that y has to equal any of these, 5 or 5. Oh, look at that. It's always going to be 5. I'm only going to write that once. Y such that y must equal 5. All right, so our next page. This is a graph that we are given, and so we want to know, does this represent a function? I'm going to imagine that I have a vertical line. My pen is going to be my vertical line, and I'm going to do the vertical line test. If I ever hit 2 points at the same time, it's not a function. Well, I hit 2 points right there. I hit 2 points there. I hit 2 points. A bunch of times I'm hitting 2 points. It is not passing the VLT. Okay, does not pass vertical line tests, so not a function. I'm determined to write my answers in the wrong spots. All right, so what is the independent variable? Remember, independent is our input, it is our x values. So I'm going to look down here at the x-axis, age of puppy. Independent is my age of the puppy. Then it says, what is the dependent? My dependent variable is my output, or my y values. So that's going to be my weight of my puppy. All right, so if I want to talk about the domain in set builder notation, remember domain is always your x's. Be careful, because if you accidentally tell me x when you mean y, you're going to get your problem wrong. So just be careful. X's are going to be my domains. So what are the possible x's I could have? I'm scanning my x-axis. I could have 1, 2, 3. So x can equal 1 or 2 or 3. 1, 2, 3, 6 or 7. Those are all of my possible x values that I could have, right? If I want to represent the range, I'm going to tell you all of the y's such that y equal some things, and I'm going from bottom to top. So if I know this is 0 and this is 20, I know this guy must be 10. So in between 0 and 10, we're going to say that's 5. So I have something at 5, right? That's at 5, and then at 10, and then at 15. And then I have 20, 30, 40, and then I have 60 is my last one, right? So 5, 10, 15, 20, 30, 40, and 60. Those are my possible y values, so that's my range. All right, so for discrete points, we're going to tell specific values that we might have for x or for y. But if we have an infinite or continuous function, then we're going to describe our domain and range using inequality statements, or we can think about what we know already from interval notation, and we can kind of translate that into our inequality statement, and we can just plug that right in. So I will let you read through that on your own, but I'm going to move us on down here. Okay, at the very bottom, if we are thinking about interval notation, is -2 and 5. Those are our boundaries. So imagine that we have some sort of a number line, -2 here and 5. Since I have this bracket, which kind of looks like it has equal sign top and bottom, right? I know that it could be equal to -2, whatever value I'm talking about. Okay, and I know that with my 5 having a parenthesis, I'm going to have an open circle. I can't really be 5. I'm talking about the values in between -2 and 5. Okay, so if I'm thinking about x, because they told me that, I must be talking about my domain. My domain is in between -2 and 5. Set builder notation is going to technically be all of my x's such that x is in between -2 and 5. So I look at my boundaries, -2, 5, and I know x is in between them. And then I think about what symbols can I use. Well, -2 is less than or equal to x, since I have a closed circle there, or I have a bracket here. And I know that x is less than 5, since I have a parenthesis there and an open circle. Okay, so this full statement is the set builder notation. Okay, I'm going to start a new video and we're going to talk about graphing continuous functions and how we write the domain and range for those. So stay tuned for the next one.